Hello everybody, we're going to be talking about 8.4 solving radical equations this time. That is expressions that contain variable expressions inside of the radical. So we call that a radical equation. A couple of examples are shown below there. The property we're going to be using is the one that says to solve a radical equation, if we have two numbers such that a is equal to b, then raising both sides to some power n makes that particular equation true. So in other words, if a equals b, then a to the n equals b to the n, right? By the way, the converse is not necessarily true. We would note, right, that if a is equal to b, if x is equal to 4, let me get my pen going here. If x is equal to 4, then it is necessarily true that x squared equals 4 squared. Right? We know that x squared would equal 16. So this would be true. But going the reverse would not necessarily be true, because if I told you that x squared was equal to 16, well, x could equal 4, but x could also equal negative 4. Right? So that added equation comes in, and how do we get that? Well, that's one thing that we have to look out for. Let's talk about a couple of these equations here first. If I have a radical equation like this, when I have a square root of 2x minus 1 equals 2, the first principle that you have to know is that when and wherever you can, you must isolate the radical. Okay, before we do anything else, always isolate the radical. So in this case, that means we're going to have to add 1 to both sides of the equation before we start doing any other action. So we have to isolate the square root of 2x minus 1. We get square root of 2x minus 1 is equal to 3. And so using this property above right here, if a equals b, then a to the n equals b to the n, we can say then that if we take the square root of 2x minus 1 and square it, it should give us the same number as 3 squared. So solving this would result in 2x minus 1, when we take a square root and we square it, we undo the radical, would equal 9. And now we continue on our way. We add 1 to both sides to find that 2x would equal 10, and therefore x equals 5. And it is a good idea to check. So let me check in a different color right here. My check goes back to the original. Right? So I would check by seeing if the square root of 2 times 5 minus 1 is equal to 2. Well, let's see. 2 times 5 is 10. That's 9. The square root of 9 minus 1 should equal 2 if we're correct. But lo and behold, we are, because 3 minus 1 does indeed equal 2. So we're good to go there. Okay. Now let's take a look at this next one. We've got a cube root. Well, what undoes a cube root other than a cube? So in this equation, since the radical is already isolated, let's erase this here. Let's try that again. We're going to take the cube root of our quantity. Good Lord, I don't know why my pen doesn't want to cooperate with me today. 3x plus 1. We're going to cube that and set that equal to the cube of 4. Well, cubing both sides of this equation results in the cube root and the cube undoing each other, leaving us with 3x plus 1 equals 64. So this is our key step right here in both of these equations, right? Our key step was using our property above to raise both sides to a power in order to undo the radical. Now the rest of it is going to be subtracting 1 from both sides, so I would get 3x equals 63. Then dividing by 3 gives me x is equal to 21. And as usual, we should make sure that we check this thing So if we check, we go to the original equation only. Right? You always want to go to that original equation. So we would have to be taking our cube root of the quantity 3 times 21 plus 1 and see if that equals 4. Well, of course, 3 times 21 is 63, plus 1 is 64. So lo and behold, our answer, cube root of 64, is equal to 4. And so both sides are equal to each other, and we're done. Okay, so more in the next video.